Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 30, Types of Chemical Reactions, Part 5. Here are our objectives for today's video. Pause here. So we're going to discuss just a little bit about acids this year. There's so much more that we could say with acids. First, I'll just give you a definition of an acid. Acids are just substances that lower the pH of water. The higher the hydrogen ion concentration, the lower the pH. You don't really need to worry about the mathematics of pH right now. That's something we get into in AP Chem after you've had a little bit more math experience. What you do need to know is that below 7 is acidic. And above 7 is basic. 7 is neutral, and also that the pH scale only really works for things that are dilute. It does not really work very well for highly concentrated solutions. Arrhenius acids are a specific type of acid that release hydrogen ions when they dissociate in water. So they typically will start with the letter H. And then Arrhenius bases release hydroxide ions when they dissociate in water. So they will end with OH. So some examples of Arrhenius acids would be our hydrochloric acid, sulfuric acid, nitric acid. All of those start with the letter H. Our Arrhenius bases will be sodium hydroxide, lithium hydroxide, magnesium hydroxide. They're all going to end with hydroxide. Pause here. So we've talked about double replacement reactions. These are very, very similar to double replacement reactions. The difference is that with neutralization reactions, instead of producing some sort of solid, they are going to produce liquid water. So the H plus from the acid reacts with the OH minus from the base, and it forms HOH, which we can rearrange to H2O. You could leave it as HOH if you'd like. It sometimes makes balancing the equations easier. That's just a matter of personal preference. Pause here. So I'm going to do this with the pre-work like we did the double replacement reaction, but you might get to the point where you don't need to do the pre-work. You might, for right now, need to actually write the acid out in order to figure out what it is. So that is what hydrochloric acid is. That is what magnesium hydroxide is. You might need to refresh on the acid nomenclature. So just like with the double replacement reactions, you may assume that the reactants are aqueous. If you look at the solubility rules and something is not aqueous, you can write it as a solid, but it's completely fine to leave it as an aqueous for a lot of reasons. But in short, the solubility rules that I gave you only really work at neutral pH. So everything aside from water will be aqueous. And then H plus reacts with OH minus to form H2O. That will be a liquid. Then I just crisscross Mg and Cl. You can assume that anything that is not water is aqueous. And then I just need to balance it. And I'll do the next one a little bit faster. You just got to remember your nomenclature. And then once you've gotten all of your formulas, you just have to balance it. The balancing for acid-base reactions should be a little bit easier than some of the harder ones we looked at with the double replacement reactions. Pause here. So I probably introduced something similar in the video number 29 in class practice. This is all just the combination of things that you have already learned before. It's just a stoichiometry calculation, but in order to do the calculation, we need to get the balanced double replacement reaction. So that's where I will start. So now it's a stoichiometry calculation. It is not limiting reagent because it says in excess silver 1 acetate. So I want to know the mass of silver 1 chloride based off of the 63.2 milliliters. So that we've already done pretty similar stuff before. And now I need to use that balanced chemical equation I just came up with. And then the question asks for it in mass. So I just need to pull up a periodic table and then I'll get the molar mass of AgCl. Then I just put it in my calculator. I'm going to round this to one significant figure because of the 4 mole. And so I should see about 9 grams of AgCl. That is all for today's video. Thank you so much for watching and have a great night.